In this video, I'm going to be explaining arithmetic series and how to write and solve them. So an arithmetic series is basically taking an arithmetic sequence and you're adding all the terms together. So in the first case of the 5 all the way through 32, basically we could pull out our calculator and easily just add all the numbers together. So you would just do 5 plus 8 plus 11 plus 14 all the way to 32. For the second one, you could still do it, except it would take a little bit longer of typing all those numbers in one at a time all the way from 1 through 100. However, what has been noticed, though, is that you can actually find a pattern in that. So, for example, the numbers 1 through 100, if you notice 1 and 100 give you 101. And if you take the second term and the next to the last term, it also gives you 101. If you take the third term and the next to the last term, it also gives you 101. If you take the fourth term and so on, it gives you 101. So really, if you notice, all of it gives you 101. So really, you only need to go from 1 to 50, adding up 101, because obviously by the time you reach 50, the other number will be 51 because they keep kind of coming closer and closer together. And what you actually deduce from that is its formula. So let me move myself over a little bit to the other side. Now, the sum of a finite arithmetic sequence, obviously you can't do an infinite because infinite goes on forever. But a finite finite sequence of n terms is given by this formula. N represent the number of terms, a of 1 represents the first term, and a of n represents its last term. So find the sum of the first 150 terms of the arithmetic sequence. So we just learned that the formula is n divided by 2 times the first term plus the last term. Now, the first term, well, we actually know a lot of this stuff. We know that there's going to be 150 terms, and we also know the first term is 5. The problem is we do not know the last term. But in a previous video, we discussed how to find the last term using this formula. We're wanting to know the 150th term. The first term is 5. The common difference is 6. How do we get that? Because it's going up by 6 every time. And then we're looking for the 150th term. So therefore, 150 minus 1 is 149. 149 times 6 is 894. So you add 5 and you get 899. So therefore, 899 was the last term. And now that you have all of your answers, all of them together, you can actually plug this into the calculator. 150 divided by 2 is 75. And then 899 plus 5 is 904. So 75 times 904 gives you your answer of 67,800. And if you were to take those terms and actually figure out the first 150 terms, and add them all together, you will get the answer 67,800. Now, in this term, we have discussed also in a previous video, this is a summation. This is sigma. This is the Greek symbol for sigma. I'm going to move myself back over here. Sorry about that. This is sigma. It means that it wants to know the sum of all these terms. So you could do one of two things. You could either actually plug in the numbers from 1 to 20, and find the sequence and then add all those sequences together. Or we can do the summation notation that we've learned. N divided by 2 times the first term plus the last term. Now, do we know how many terms? Yes, we start with 1 and we go up to 20, which means we are looking for 20 terms. Do we know the first term? Yes, we can plug in 1 to find the first term. So if you plug in 1, 3 times 1 is 3, plus 2 is 5. And then can we plug in the last term? Yes, we can actually plug in 20. 3 times 20 is 60. 60 plus 2 is 62. And now we have 20 divided by 2 is 10. 62 plus 5 is 67. Multiply by 10, so your answer is going to be 670. Again, these terms are found by plugging in 1, So 3 times 1 plus 2 will get you that term. And then plugging in 20 will get you that term. And you're able to find the answer. Now, again, in this case, I specifically told you it was an arithmetic series. There's going to be times to where you're going to be getting a sigma notation and you're not sure if you're allowed to use this formula, because if you remember, the formula is only for arithmetic series. But because you have a number that is multiplied by a digit, multiplied by a digit by 3, 4, 2, -1, -7, then it basically is probably going to be an arithmetic series. But if you're not sure, plug in a couple of the first 2 or 3 numbers so that you can see if there's a common difference. So like if I plug in 1, I will get 5. If I plug in 2, I will get 8. If I plug in 3, I will get 11. If I plug in 4, I will get 14. And there is a pattern. What does it go up by? It goes up by 3, which is very interesting. Yes, there's a correlation. Whatever that number is in front, that is actually what is going to end up your common difference. Now, and this is a little different. I give you the sum of them. I tell you where the end one, I tell you what the last term is. So let's find out what all we will need to find for our formula. We know it is n divided by 2. We know it is our first term. And we know it is our last term. So let's see what we can actually represent. Well, we know the first term. It is 7. And nicely, we know our last term. It is 103. Here's our problem. We don't know which term. Was that the 20th term? Was that the 30th term? Was that the 15th term? Was it the 19th term? We don't know how many terms are in this sequence. We don't know how many terms it took us to get to 103. So we got to pull back to our arithmetic formula, which is the first term plus d times n minus 1. What we're wanting to know is what value of n got us to 103. We know our first term is 7. We know that the common difference is 2. Why? Because it goes up by 2. And we don't know how many terms it took to get to 103. That's why we actually plug in 103 here. So we have 103 equals 7 plus 2n minus 2. So we have 103 equals 5 plus 2n. So we are going to subtract 5 and get 98 equals 2n, and n equals 49. Now we actually know n. So therefore, 49 divided by 2 times 7 plus 103. So 103 and 7 obviously is 110. So 49 divided by 2. And then multiply that answer by 110, and you get 2,695. An auditorium has 40 seats. An auditorium has 40 rows of seats. There are 20 seats in the first row, 22 seats in the second row, 24 seats in the third row, and so on. How many total seats are in the auditorium? Well, if you think about it as an arithmetic sequence, we know that there's 20, 22 in the second row, 24 in the third row, and so on. And we know that there's 40 rows of that. So we actually have created an arithmetic sequence in this case that we know the sequence. Our sequence is, or we can find the formula for it. The formula is the first term plus the difference, which we found is 2, because it goes up by 2, times n minus 1. Now, but we're wanting to know how many total seats there are. That is the summation one, which is n divided by 2 times the first term plus the last term. Well, we know that there's 40 terms because there's 40 rows of seats. And we know that the first row has 20 seats. However, we do not know the last row. So we're going to go over here to our formula in order to figure out how many were in that 40th row. So therefore, we are going to actually plug in 40 into that, into n in order to find our answer. 40 minus 1 is 39. And then 2 times 39 is 78. And then 20 plus 78 is 98. So we know that the last row, the 40th row, has 98 seats in it. Now we can actually solve this. 40 divided by 2 is 20. 20 plus 98 is 118. And so, I'm sorry, it is 2,360 seats are in the auditorium that they can sell tickets for.